Right, this is the second video for chapter 22. Still talking about electrostatics, which is going to be electric charges at rest. This is covering pages about 417 to 421 or so. So there are two methods really for charging an item or transferring a charge. So the first one is charging by contact or conduction. So if you'll remember from when we did heat transfers, you had conduction and convection. Well, conduction is when you were touching the heat source through the solid to change the temperature. When you're doing charging by contact or conduction, it is by actual touching it. So the electrons are going to be transferred by touch. So if we had this neutrally charged ball, when we do this in lab, we call it a pith ball. It's just a little piece of ball or wood that is not charged. You take a rod or a strip and you charge it by using friction. You can create a negative or a positive charge on that rod. Now, when you bring that rod near to the ball and you touch the ball with it, those negative electrons are going to transfer over. They are being conducted over there. They are transferred by touch or contact. Once they do that, they are actually going to spread out around the surface of that ball, and it is no longer uncharged. It is negatively charged. So charging by contact, if you have something that is negatively charged and you're wanting another item to be negatively charged, you would charge by contact because it's going to keep the same charge. Likewise, if you charge that that strip and made it a positive charge, then you could charge the pith ball and make it a positively charged ball. The second way is charging by induction. Induction is when you bring a charged object near an uncharged object, and you can create a charge on the uncharged object because the electrons will shift around. So you don't actually touch it, you just get close to it. So let's say we had our uncharged pith ball, and actually it's not that it doesn't have anything in it, it's just that it's neutrally no charge because it has equal number of positive and negative charges inside. So if we have our uncharged ball here and we have our charged rod that is negatively charged, when we bring our negatively charged rod next to our uncharged ball, what's going to happen is the negative charges on the rod draw the positive charges in the ball toward the rod and the negative charges onto the opposite side. And so what we're doing is we're creating a charge within that object because it is near the negative. Now, once you remove that rod, then they would actually go back to being normal. So what you can use this for is if we have two balls that are identical that are touching and we have our charged rod, when we bring our rod nearby, what you'll do because they're touching is you'll get all the positives in one ball and all the negatives in the other, so that if you split them up, now you have a positively charged ball and a negatively charged ball. And so those charges would actually spread out and fill the whole entire thing. So if you're wanting to get an opposite charge, you would want to charge by induction. So if you want to transfer the same charge, you want to charge by conduction or touch. And if you want the opposite charge, you're going to charge by induction or not touching it. It's just coming close. All right, so thunderstorms are an example, a natural example of charging by induction. So you've got your cloud and you've got your ground there. And in your cloud you have, excuse me, inside the cloud you've got lots of the water molecules are bumping into each other and rubbing around and banging into each other. And that friction causes a charge to start to build up. The negative charges are going to build up on the bottom of the cloud. Positive charges are going to build up on the top of the cloud. Once you have enough charges building up in that cloud, that negative charge on the bottom of the cloud is actually going to induce a positive charge on all the things that are on the ground. So the ground, the trees and the plants and the buildings, they're going to build up and build up and build up. And the more they build up, you're creating an environment where a discharge needs to happen, where those negatives and positives need to touch in order to release the tension from them. So when you have that happen, then you have a lightning bolt. So one of the things that, especially back in times when most things were built out of wood, a thunderstorm with a lightning discharge could really cause a lot of havoc in the world, and a lot of fires would happen. Some really big fires would break out in cities, and cities would burn to the ground because everything's made out of wood if a thunderstorm comes. So the whole idea of a lightning rod, what it's doing when it's when they put the lightning rod either up on a building or up on a house, what it's actually doing is it Benjamin Franklin figured out that the sharp point, that charges will flow better if you have a sharp point for them to flow to. So the lightning rod has a really sharp point on the end, and that is able to collect some of those positive charges. So rather than it building up everywhere else, it's building up only on the pole. And so when it does that, it can either prevent lightning from striking the building altogether, or it can at least control it. So that if lightning does need to strike because it needs to have a discharge, it can kind of direct that lightning from the building itself down to be grounded into the ground, so that none of the electronics happen and go out in the building, or that there's not a fire at all. So there's lots of things that a lightning rod does. It's not just beautiful on the building. It is to protect from a lightning strike, so that if it does strike, it can ground it and prevent a fire. So there's two ways that I told you, the two ways that you can charge a normal conductor, right? But what about an insulator? So the way insulators get charged is through polarization. So it's not really that the electrons are moving from one to the other like induction. I showed you in the pith ball, you could have a positive one and a negative one. Polarization isn't really that the electrons move like that. It's just that the individual charges will shift so that you have something that is polarized. An example of that would be like water molecules. The way they share their electrons between the hydrogen and the hydrogens and the oxygen cause for a water molecule to be more negative on one side and more positive on the other side. So anything that is like this, those molecules are going to be electric dipoles. If they are polarized, we say that they are electric dipoles, meaning they have two poles. They have a positive and a negative. Click on the link, finish the homework, and take the quiz, and we'll see you in class.